Hello guys, welcome to my renewable energy resources representation of IHAV. Today we'll be finding out the renewable energy sources, as you can understand from the title, and we'll be finding out what are the pros, what are the cons, and how they might work in the global means of energy reproduction. We'll be finding it out. Well, let's start. What is renewable energy? Renewable energy sources are inexhaustible energy sources, which by any means is understandable that they don't run out and they kind of exist forever. Unlike fossil fuels, which require significant effort, time, and expensive heavy machinery to produce, solar, wind, water, or biomass energy directly converts natural resources into electricity. Turning into renewable energy sources not only offers economic benefits but also protects the environment by reducing the total amount of greenhouse gases produced by human activities, which we call the carbon footprint. What are the types of renewable energy? First, we got solar energy. Let's read the description. Photovoltaic cells, which convert solar energy directly into electrical energy, are made from semiconductor materials such as silicon, as you might have already known it. When sunlight strikes photovoltaic cells, it is absorbed by the semiconductor materials releasing electrons. These released electrons can be used to generate electrical energy when they become part of an electrical circuit. Well, we got a fun fact down there saying the sun has enough energy to meet the entire world's energy needs for 1 year with the energy it sends to Earth in 1 hour, demonstrating the potential we get from sunlight in terms of energy usage, which is actually kind of pretty fascinating to think about, in my opinion. Well, second energy sources we have is wind energy. Wind power is an important renewable energy source. Wind turbines, which convert the power of the wind into electrical energy, operate on a similar principle to windmills that were formerly used for grinding grain. As the wind rotates the turbine blades, mechanical energy is converted into electrical energy in generators. At the left, we can see the wheel of the fields of wind turbines generating energy for human use. And down there, we can see the map of Turkey, and these little red dots represents the probably must be representing the renewable, I mean the wind energy fields operating in Turkey. You can see that most of them are concentrated in the west side of Turkey because this is exactly where we're getting all these wines from. And we have some severe amount of wind energy fields in what I call as the middle of Anatolia, Turkey. Yeah. Kinetic energy of rivers and waves. In wave energy systems, electrical energy is generated by utilizing the movement and pressure of waves. Wave energy system can be installed on a coast, near the coast, or offshore. There are different types of wave energy power plants. As you can see the image on right. Yeah. The fourth one we have there is geothermal energy. Geothermal energy is the energy obtained from underground water heated by the heat at the Earth's core. In geothermal power plants, steam or hot water is brought to the surface through boreholes drilled underground and pumps. The steam then rotates turbines, which in turn generate electricity in generators. At the left side, we can see image, and let's see its description. The ancient city of Hierapolis in Pamukkale, a UNESCO World Heritage Site, features ruins dating back to the 2nd century BC, indicating the use of geothermal energy for heating. Uh, we are, speaking of Turkey, among the top 11 in the world and fifth in Europe in renewable energy. By generating electricity from renewable sources, we are about preventing imports and gradually approaching our 2053 net zero carbon target. As you can see that China is literally carrying in terms of built-in power, and it is first. Then we have United States trying to catch China, though the difference is significant, as you can see from the chart. Then comes after Brazil, the fourth at the fourth place. We got India, and the fifth one being Germany here. We surpassed Russia, the UK, Australia, and Vietnam in terms of built-in renewable energy power. How do the circuit components on the training set work? Uh, the first one to mention here, as you can see from the picture, is solar panel. The solar panel at the top of the image consists of photovoltaic PV cells. Cells are the main component that makes up a solar panel. A solar panel is formed by connecting numerous cells in parallel and series. It is made of monocrystalline and or polycrystalline silicon material. The bottom semiconductor is the positive charge. The top semiconductor is negatively charged. When the top semiconductor is exposed to light, the electrons move to the positive charge below. This movement of electrons creates an electricity current, and a direct current, which is the abbreviation, we call it as DC here. Electricity is produced. The current is transmitted to the electric charge via conductors. This set typically produces a nominal voltage of 20 volts. The generated electricity flows through red and black wires to the charge controller. What happens at this stage is that sunlight is directly converted into electricity. There are no mechanical parts such as motors. It is completely silent and instantaneous. Sorry. Uh, Second material we got in this built-in system is or are charge controllers. Um, the box with the blue screen on the right is this device. By the way, the reason why I call it charge controller or controllers is that like the amount of charge controller in a built-in system actually depends. Like I mean in this system we use just one, but some other systems consists of charge controllers more than one. Just in case you might just use this information somewhere. Anyway, its function is to ensure the electrical current coming from the panel is safe and controlled. It protects the battery from overcharging. It cuts off charging when the voltage reaches around 14.4 watts. It prevents the battery from deep discharging. It cuts off the load and the voltage drops too low. It is usually a PWM type controller, very common in these small kits. Thanks to the USB ports, you can also charge phones and other devices directly. On the screen, you can see values such as the power produced by the panel and the battery voltage. What happens at this stage is that raw solar energy is regulated. If we connect it directly from the panel to the battery can be damaged. This device provides protection and avoids such a case from happening. The third component here is battery. Battery shown in the picture is a power extra 12 watt 7 amperage hour lead acid gel battery. The electricity from the charge controller is converted into chemical energy and stored here. The reason why it's called chemical energy is because the lead acid gel component it includes. This is why it's called chemical energy here. While the system is operating, it both charges and powers the load, which is what we also call it lamp in this case. What happens during this stage is that energy is stored even if there is just no sun. The lamp continues to operate from the battery. This is an advantage unit that is set. Uh, the fourth component we need to be talking about is load indicator. The small blue screen on the light, like if 13.3 watts is displayed on the screen, uh, that means that it actually takes some power from the battery, takes that amount of power from the battery, we gotta call that. If it's 0.00 amps, the current is 0 and the lamp is off. 0 0.0 watts, if it displays it like that, then that means instant power. Other values indicate the energy consumed by the load. This screen reports the system's heartbeat in real time. Fifth component is load or load consumption plus load on and off. The LED tube lamp in the picture is the load off in the system. Off the system, the load is switched on and off with an on-off switch. When the lamp is on, electricity flows from the battery or directly through the controller and produces light. You can see the cables in orange. These indicate the load connection. What happens at this stage? The stored energy is converted into usable work, which is light. The system is fully operational. System flow. Down below this capture states that of course the first step is on the solar the sun, then panel, charge controller, then battery, then load indicator, and then load, which we also can call it as a lamp in this built-in system. Factors affecting charging time, instantaneous power of solar panel. The stronger the panel and the more directly it is exposed to the sun, the faster it charges. Cloudy weather, shade or incorrect panel angle, if it is horizontal, for example, reduces power by 50 to 80%. The charging time here increases. Charge controller type and current. The blue box in the set is PWM type. PWM is 20 to 30% less efficient than MPPT. Current charge status of battery, which we also can call it as deep discharge. If the battery is old or sulfated, left idle for a long time, meaning the left side is not at work for a long time, the charging time increases and capacity decreases. Load usage: if charging continues while the lamp is on, some of the energy produced by the panel goes to the lamp or directed to the lamp. The battery charges slower or not at all. Temperature, other losses: the battery charges slower in cold weather. Cable quality, connection resistance, dusty panel is equivalent to extra loss. Whoops. Uh, how to practice with the set. On a sunny day, panel facing directly into the sun, lamp off, the battery will charge significantly in 6 to 10 hours, which is something we want to see happening for sure. To understand when a charge is complete, if the voltage on the load indicator rises around 14.4 watts, at the current drops, charging is nearing its completion. The charge controller will then automatically cut off the charge. Avoid over discharging the battery. Deep discharge shortens the battery's lifespan. This small 7 ampere hour battery is sustainable for quick testing as it is intended for educational purposes. In short, charging time depends on a combination of panel power, solar quality, and efficiency losses. The biggest factor is how strong and for how long the sun shines. And a sustainable world, clean energy, zero carbon footprints are the ones we must be looking for. Join the MTAL Renewable Energy Team. Renewable Energy Teamwork includes weekly technical meetings, circuit design training, auditing applications, energy measurement experiments, project journaling, workshops, solar charging station, solar tracker, mini wind turbine, smart street lab, hybrid solar wind system are what we are working for in workshops. Well, as this representation ends here, uh, I personally thank you for listening. Uh, Also, special thanks to the captain of the renewable energy team, who is Mustafa Nevzat Keklik. Well, see you in another educational video. Bye bye.